So the first thing that I'm going to look at is I'm going to look at ray diagrams for converging mirrors. So similar to lenses, I will only use two rays, just like I did before. I have ray 1. This is the one that's parallel to central axis, reflects and goes through the focal point. Then my next ray will be ray number 2. And this one, what it does here is that it's a ray that reflects from the middle, from the middle of the mirror. Okay, so let's go through all of the converging mirror ray diagrams. And state the image characteristics. So what I'm going to do here is that I'm going to copy the same ray diagram for each situation. So here I go. So the first thing I'm going to do is I'm going to create a mirror. Okay, so I'm going to take a shape. And let's say I'm going to go 1. Say I do that. I want to make sure I get this way. 1, 2. Okay, good. So now I'm going to make this a converging. So I'm going to add that little end right there. So now what I'm going to do here, you know what? That's a little bit thick for me. I'm going to make that thinner. So that's going to be my ray diagram right there. My mirror. And I know that this guy is going to be positive, and I want that central axis to be in the middle. So what I'm going to do here is that I'm going to have my central axis go like this. And because this is a converging, I'm going to say that this guy is F and this guy is 2F. So this is 2F. Then I'm going to call this one here F right here. So I'm going to copy this. And then that way we could save some time by going through these guys. So here we go. So now that I have that, This one I'm going to extend a little bit farther. And the reason why is because now, what am I going to do? I'm going to say that our first case that we're going to look at is we're going to look at an object outside of 2F. So let's go do this. So here's my object right here. So in each of these situations, you're going to see that I'm going to keep moving my object and I'm going to move it towards the lens. So you'll see I'm going to be outside of 2F, then I'm going to be between 2F and F. And just to restate what happens when you're at the focal point, I'm going to look at this situation. And then I'm going to go right inside the focal length. And now you could see how I'm going to label these. So then this guy's going to be 2, and this is going to be 2F greater than S greater than F. So now let's look at ray number 1. So ray number 1 goes parallel. Now reflects and goes through the focal point. So this is ray number 1. So now ray number 2 here, I think I'm going to use a green. Now look what I'm going to do here. So the way you want to do that is you take the object and you create an image point. Okay, so you could see that I take the top of the object and I create an image point that's at the exact same height. So now here I go. So then what I'm going to do here is that it's going to go to the center and then it reflects at the exact same angle. So now if I do that, then this is ray number 2. And so what you're seeing here is that now I have an image that's formed where these rays cross. And you can see here, so if I compare the object to the image, you could see right away that this is going to be inverted. This is going to be smaller. And because it's on the same side as the object where the light should be, it's going to be a real image. Now, I'm going to move this one here because this can get quite large. So I'm going to try to be careful and put it right here. So now let's do this guy. So in this case, I start again with my rays parallel to the axis through the focal point. So if it goes through the focal point, it's going to look something like this. Again, this is ray number 1. Now let's look at ray number 2. Remember, I picked that image point. So now if I pick that image point, it's going to go like this. It reflects from the same angle. And it has to go through that point. And you can see here is that the object is where the rays cross, or the image, excuse me. And that's where this guy is located at. So if you look at this, you can compare the two. You can clearly see that the image is, again, inverted. It's definitely larger. And because it's on the same side as the object where the light's supposed to be, it's a real image. Now, let's go look at this guy. So in this situation, I'm going to put this at the focal point. And what happens at the focal point? Those rays should be parallel. So Let's see if they're parallel. Okay, then they go through the focal point. So now, if I pick, again, look at that image point. So now I'm going to look at the ray here. And it has to go through that image point. And you could see that those two rays are parallel. Once again, we have that railroad situation. So here, because our eyes deceive us, we say that these rays cross at infinity. And we say that that image is at infinity. So we say that the image is at infinity and it's infinitely large. But, you know, that's just because of, that's the way, what our eyes are doing. So now, in this situation, I said that this was, this would be 3, and this is where S is equal to F. So now we're at 4, and we're going to say that F is greater than S. So we do the same thing again. So now if I look at this, oops, wrong color. My ray comes in, it goes through the focal point. And then if I look at the image of this point, here's my point, my ray has to come and it has to reflect through the center. And what you're seeing here is that these rays are diverging. Because they're diverging, our eyes follow the rays backwards. So now, if I start following these rays backwards, I start to see in this direction. And if I look at my red here, I start to follow these guys backwards. And it appears that all of the light is originating from behind the mirror. Now we know that that's impossible because of the aluminum backing. You can't do that. So now we see that this image is what? It's erect. And as soon as you see an erect image and it's larger, we know that this has to be a virtual image. So now what I want to do here is that I want to set up the same type of thing as before. I want to draw one comprehensive ray diagram. So I want to look at a comprehensive ray diagram that contains all possible image formations. And so I just copied this from the previous one, and I'm going to leave it right here. Okay, and I want this on a line. Okay. So what I'm going to choose here is that I'm going to choose to try to spread out the images. I'm going to choose a focal point here. So they're 2.5 squares. So note, I'm not going to write 2F and F here. So what I'm going to look at is I'm going to create my object, and I'm going to say that my object is going to be 2 squares. And here's my object right here. And I'm going to set it outside of 2F. I'm going to bring it to 2F. Then I'm going to go inside 2F and F. I'm not going to do at the point F equals to S, and then I'm going to bring this guy inside the focal point right here. Okay, so let's look at that. So there's only one ray diagram for ray number 1, and it's the same for all of them. And they all go through the focal point. Now, because of the diverging, I'm also going to go behind here. I don't know how far I need to go, but this guy right here is ray number 1. All of the other rays are going to be ray number 2. So here we go. So the first thing I'm going to do is check this out. I need my image point right here. So if I have my image point, then I need that reflection right there. So I'm going to go from here. Then I got to do my reflection. And then here's my reflection right here. And you could see here is that I'm going to create an image that's right here. Now I'm going to change color, and I'm going to use blue. So look at this guy. Here's my image point right here. Oops, that's too big. So here's my image point right here. So that ray has to go through there. So now let's go look at that. You could see that this ray is now changing angle. And it's this ray that determines where that image is going to cross. And you can see that it crosses at the exact same location as 2F, exactly like we expected. Now, let's take another ray. And I'm going to use this yellow one, so I'm going to come in here and I'm going to pick this point right here. So I know it's got to reflect through there. And then here's my reflection right here. Uh-oh, I'm not gonna, uh-oh, I didn't make it, the red one long enough. So let me go back and make the red one longer. And you could see that that image crosses right here. And if I start to label these guys to try to make it a little bit more clear, note that this guy was S greater than 2F. This one was S equal to 2F. And then this one over here is 2F greater than S greater than F. And now we're left with our last one right here. And what does it do here? I got to create my image point. So then it goes like this. And because these rays diverge, our eyes follow it backwards. So then you can see here is that this guy right here is my virtual image for F greater than S. So you could see here that the rays are doing what? On the left side, you see that all real images are inverted. With various sizes. Over here, we're seeing that all virtual images are erect and larger. So if you look at a mirror and you see that it's larger and erect, you know it has to be a converging. Now, one of the things that I want to do here is that I want to look at Duffy's mirror applet. Because it will give us the overall view of what I'm trying to get right in here. So let me go do a new share. And here's what we're looking at. We're looking at Duffy's converging mirror. The red here is the object. And you could see that this is the image right here in purple. So what I want you to look at here is that as I move the object, look what happens to the image. So if I move this inwards, you could see that the image is moving to the left and getting larger. And it gets larger and larger. And then at the focal point, the rays are parallel and do not cross, but they cross at infinity. And then it crosses over to infinity. And you could see here that they're now virtual. One more time. Look at the flow. As you move inwards, the image grows in size. And then as soon as you cross the focal point, you go from a real to a virtual image instantly. And that's because of the singularity of those equations. So the last thing we need to do here is that we need to go in and we need to look at diverging mirrors. So what I'm going to do here is that we're going to move here fairly quickly here. So now we're going to look at the ray diagrams. For diverging mirrors. The difference between a converging and diverging mirror is the focal point location. And so if we look at this thing, let me draw a central axis. So now if I come in and I create a lens, let's say that in this situation, I have a lens that looks like this. Let's say that this is a converging lens. And then in this situation, I'm going to go create a diverging lens over here. So that when I look at this thing, I see this. This is a positive focal length. This is a negative focal length. We then say the following thing, that this guy right here, this is the focal length on this side. And look, my language is sloppy here. So I'm going to call this the near focal point to the object. So that means it's on the same side as the object. So if I have a converging mirror, then when I look at my ray diagrams, these guys all are crossing through the near focal point. It's not the case for a diverging mirror. The big difference here is that the focal length, I'm going to say that here, when I look at this, this is the far focal point to the object, which then means it's on the opposite side of the object. So then when I focus on those rays, that's what I gotta look at here. So in this situation, if I have this one, we know that it's going to be diverging. So when we do our ray diagrams, they have to come through that focal point, right? They have to come through that focal point. So when you're drawing them, this is what you got to pay attention to, just like we did with the diverging lenses. So then we could then do the same type of thing that we did before here. So what we did before is that I'm going to set up, I'm only going to do 3 diagrams. But I think we will get enough information. And you know what? This is too long. We don't need that. So I'm going to erase part of this to be about right there. And this is what I'll copy and use. So I'm going to copy this here. So I'm going to put this, let's put this right here. 1. 2, then I'll put a 3rd down here. So if I pick 3 of them, I'm going to pick that 1. I'm going to pick S is greater than 2F. So I'm going to make this 1, 2, and then I'm going to pick 2 back here. So remember, this is the only one that's important is this guy. I don't care about anything else. So here's my first object. And my first object is going to be outside of 2F. Then I'm going to go inside of 2F. And then I'm going to go inside of F. So then let's go look at the ray diagrams. Let's start drawing them. So here I go. So this is ray number 1. It reflects through the focal point. It diverges the ray, but then our eyes go backwards. Now I do the exact same thing as before. What am I going to do? I'm going to pick my image, my reflection point. And so if I look at my ray, then it's going to look something like this. It's going to reflect here. Now I follow the ray backwards as it goes through that reflection point. And so you can see here that this is my image. And right away, you could see here that this is going to be erect, smaller, and because it's on the opposite side, it's going to be virtual. Now, as you could see here, so this is about half of a square, and it's about 1.5. Now look what happens. I'm getting closer to the mirror, and I have this. Again, I go right through here. Now I've picked my image or my reflected point right here. So now let's do the same thing here. And I follow this backwards. And what you're seeing here is that the image is a little bit taller, but also a little bit closer. So in this case, this is still erect, smaller, and this is virtual. But what this is really telling us here is that it moves closer to the mirror and grows larger. So if I look at this final one, oops. Gonna look like this here. Now I need my reflected point right here. So then drawing this out. Oh, you could see that the image is clearly moved closer and it is clearly larger. So again, it continues the same trend. So it's still erect. It's smaller and it's virtual. But you could see that it's definitely getting closer and larger. So now let's do the last one of all of the possible images. So this will be a comprehensive. Let me move this over here. So I'm going to draw a comprehensive. Ray diagram. That contains all possible image formations. So this time I want to draw something longer. So what I'm going to do here, I'm going to make this a thick one. And I want, let's see if I can do this long. Okay. Now what I'm going to do here is that let's draw my axis. And I want to spread these out as much as I can. So I'm going to pick a focal point that's a factor of 3. Okay, this way the rays will get really separated. So now my image, my object, excuse me, is gonna start outside of that 2F point. Then I'm gonna go in between these two. You know, maybe we should do the 2F so you could see here. That 2F is not going to land here. So then this one, I want to make it further out. And then finally, we're going to go inside. Okay, so let's look at the first one. So the first one is ray number 1. So it comes this way. And it does so for every single ray. And then I follow it backwards. That ray never changes. So now let's look at this thing. So the first one I'm going to look at is I need my image point or my reflected point here. So here's the first ray. Then it comes like this. Now I follow it backwards. And you could see that that's my smaller erect virtual image. Now let's go to the second ray. The second ray, look how I'm going to pick my point right here. So then it's going to look something like this here. You know what? I'm going to get this slightly different color. So then I'm going to go from here to here. And then I got to follow this guy backwards. Oh, wait. I put this one in the wrong spot here. This guy goes right here. So then I follow this backwards. And you can see that the ray has increased in size right there. So what's important about picking the one at 2F, you can see that it's not the same size. And it's not a 2F. Now let's get the next one here. So here's my reflected point. And so then if I come here, now I go through my reflected point. And you could see that the image is growing. So now if I go get another one, let's say I get this pinkish one. Now here's my reflected point right here. And it goes here. Oh, wow, that's pretty far off. Here, and then it goes back. And you could see how these images are growing. So we could see that you could see the increase in the image size as you go in that direction. So as a final thing here, let's go look at the Duffy's mirror applet. just to show the flow of what is actually happening. So the way I go from converging to diverging is down here, they have a diverging. Now, what I can do here is that I'm going to get way out here and look at that. If I'm far away, then the erect image is close to the focal point. But now as I move in, you could see that the image point is growing. And look at ray number 1. You could see how it's following ray number 1 in height. It's growing in size, and it's the largest right at the mirror.